All right, now I'm going to go over how to use Kirchoff's laws when we have a circuit with two loops. And if you remember, if we have two loops, we have two equations, an equation for this loop and an equation for this loop. However, we have three unknowns. We have I1, I2, and I3, which are unknown. So that means we have three unknowns and two equations. So we need one more equation to solve this system. So we'll have three equations and three unknowns. So now we have to introduce his junction rule at point D. And remember, his junction rule at point D is just, you have to look at the currents going in and the currents going out. So for this one, since I have I1 going in, it's going to be plus I1 minus I2, since it's coming out, minus I3. So when I put these into my matrix, and remember, you have to put this in your matrix too. The first row is going to be plus 1, minus 1, minus 1, 0. Now to analyze the two loops, the first thing we want to do is we want to draw our loop. So I'm going to draw this loop and call this loop A. And I'm going to draw a loop down here and call it loop B. And you could have chosen the other direction, but I just chose this direction. So now let's analyze this. And before we analyze it, note, in the previous problem, it was an I1, I2, or I3 in the loop. And that meant that I1 was flowing all throughout, or I2 was flowing all throughout, or I3 was flowing all throughout. Now that's not the case. Now the current's splitting. So I1's flowing, and then it splits into I2 and I3. So I1 is no longer going all the way around. So what happens is we have I1 flowing all throughout this part. We have I2 flowing all throughout this part. And we have I3 flowing down this middle branch. So when I do my loop equations, they're going to look as follows. So loop A. Let's start at this 24-volt battery. Looking at loop A, it's flowing from the negative to the positive, so it's going to be plus 24. Now looking at this 4 ohm resistor, current 1 is flowing through, and current 1 is going to the right, and loop A is going to the right. So it's going to be same direction, so minus, not plus, but minus 4 I1. Likewise, for this 2 ohm resistor, I1's flowing through it, and it's flowing down. And if I look at the loop, it's going to come around and flow down. So it's going to be minus 2 I1. And then looking at this 3 ohm resistor, the current's flowing to the left, and it's I3 flowing to the left. And this loop is going around, and it's going to be flowing to the left as well. So it's going to be plus, it's going to be minus 3 I3. And it's minus because the current's flowing to the left, and this loop is going to the left. And it's going to be all equal to 0. Notice there is no current 2 flowing anywhere in this loop. Current 2 flows in this loop. So if I simplify this, it's going to be negative 4 minus 2, which is negative 6 I1 plus 0 I2, and it's going to be minus 3 I3, And then it's going to be, move that 24 to the right, it's going to be minus 24. Now looking at loop B, remember you can start anywhere. I just like starting at the batteries. So the loop is flowing from negative to positive, so it's going to be plus 12. Then looking at this 3 ohm resistor, it's getting current 3, and the loop is flowing this way to the right, but that current's going to the left, so it's going to be plus, because they're in the opposite direction, I3. Then looking right here, the current's going down, just like the loop is going down, so it's going to be minus 1, and that's getting I2. So minus 1, I2. And then looking at this 5 ohm resistor, it's going to the left, and the current's also going to the left. The loop is also going to the left. So it's going to be minus 5, I2. Note how there's no I1 in this equation, because I1 is only in loop A. So it's going to be minus 1 minus 5, which is minus 6, and that's I2. There's 0 I1, and then it's plus 3 I3, and then move that 12 to the other side, and it's going to be minus 12. Let's write this one, minus 12. Now I can use my calculator, and I can enter all these into my matrix. It's still a 3x4 matrix because it's 3 rows and 4 columns. So second, let me turn on my calculator. Clear. Second matrix, go over to edit, click the 3x4, and I'm gonna enter 1, negative 1, negative 1, 0. Then it's gonna be negative 6, 0, negative 3, and then negative 24. Then it's going to be 0, negative 6, 3, and then negative 12. So then I'm going to exit out, go back to matrix, move 1 over to math, and then click RREF, and go second matrix, click the matrix that I want. And what I'm going to find is the answer 3.5, 2.5, and 1. So plus 3.5 plus 2.5 and then plus 1. Remember, if one of these is negative, that just means the current is flowing in the opposite direction of what we drew. And that's the second matrix. I mean, not the second matrix, that's the second circuit with 2 loops. All right, I'm gonna go over one more circuit. And it's another 2-loop circuit, and it's just gonna be for practice. So the first thing you wanna do is look at your junction rule. And it says at point B, so at point B, I1's going in, I2 and I3 are going out. So it's gonna be plus I1 minus I2 and minus I3 equals 0. And you're going to analyze these 2 loops. So you're going to do loop A, and then you're going to do loop B. And then remember that current 1's flowing. Sorry, my arrows are a little bit ugly. Like this. And then it splits. And current 2 flows down. And then current 3 flows this way. So let's analyze loop A. We can start anywhere. I'm going to start this 5-volt battery. So the loop is going from the negative part to the positive part of the battery. So it's going to be +5. And then right here, note that all 3 of these are going in the same direction as current 1, and it's getting current 1. So it's going to be -30 I1, -20 I1, and -40 I1. And then this, for the 15-volt battery, the loop is going from the negative part to the positive part. So it's going to be +15. And right over here, I2 is going in the same direction as loop A. So it's going to be -5 I2 -10 I2. And then the loop is going from the positive part to the negative part of the battery. So it's going to be -9. Is equal to 0. So simplifying this, I got -30, -20, and -40 I1, which is -90. -90 I1. And then for I2, I have -5 -10, which is -15. And then there is no current 3 flowing in that loop, so +0 I3. And then I have a 5 + 15, which is 20, and that 20 - 9, which is 11. And when I move that to the other side, it becomes -11. And then for loop B, I'm going to start the 9-volt battery. So it's going, looking at the loop, it's going to be +9. And then note that the loop is going up, but current 2 is going down. So it's going to be -5 -10. I mean +5 +10, because they're going in the opposite direction. The loop is going up, the current's going down, so it's positive. So +5 I2 +10 I2, because I2 is going through those two. And then all of these resistors are going in the same direction as the loop, so it's going to be minus. So -35 I3, -15 I3, -25 I3. Now I have to deal with these batteries. The loop is going from the negative part to the positive part, so +12. And then same with this, going from the negative part to the positive part, +8 = 0. So it's going to be +0 I1, because no I1's going through. It's going to be +15 I2, because 5 + 10. Then for I3, it's going to be -35 -15, which is -50. -50 -25, which is -75 I3. And then I have 12 + 8, because of these two batteries, is 20. And then I have that 9-volt battery, which is 29. So when I move that 29 to the other side, it becomes -29. So I'm going to put these numbers into my matrix. So I'm going to go to second matrix, go over to edit, and then it's going to be +1 -1. Oops, sorry. It's going to be plus 1, minus 1, minus 1, 0. Then it's going to be negative 90, negative 15, then 0, then negative 11. Then it's going to be 0, 15, negative 75, negative 29. Then I'm going to go to second matrix, math, go all the way down to RREF. I'm going to go to second matrix. I'm going to click the matrix I want. What I get is 0.15, so positive 0.15, negative 0.20, and then 0.34. And this is the second example for a 2-loop circuit.